concepts and the terminologies involved in the hypothesis testing process, we will look at some of the common test statistics for the various statistical tests and do some kind of calculations and try to go ahead with our conclusions. So to start with, we will go ahead with the first aspect, which is the testing the means of the normal population. So testing the mean of a normal population, so which means population, if it is normally distributed, if the population is normally distributed, I want to test a hypothesis whether a population mean is equal to some predefined value or not. Statistically, is there any kind of a difference between the predefined value based on what data we collect from the sample? So we are going ahead with a null hypothesis in this process. Here there are two variants. One is when the variance is known, variance of the population is known in advance. The second variant being the variance of the population is not known in advance. In most of the realities, in real world application, it falls into the scenario of where we don't know the variance of the population. So how do we really go ahead? So probably a simple couple of statements if I have to make. I want to test whether the mean height of an Indian male, is it equal to 165 centimeters or not? So that is what I want to test. So what is the scenario here? I mean, forget about whether the variance is known or not known. If at all I know the variance, I'll use the first mechanism. If I don't know the variance, I'll go ahead with the second mechanism. But overall, the test is about testing for the mean of a population by doing some kind of test on the sample data. Alright. So let's see, if at all the variance of the population is known, we will use the test statistic, which is nothing but the sample mean, which is x bar, the sample mean minus the hypothesized mean divided by sigma by root n. We know that sigma means the population standard deviation, and now that we have said that the population standard deviation is known, we can take the population standard deviation and divide it by root n and say that this entire calculation, we'll take it with an example, x bar minus mu naught by sigma by root n follows a normal distribution with a mean 0 and the variance equal to 1. And in case the population mean standard deviation is not known and I have to test for the population's mean, all we are doing is, because we don't know sigma, we are taking S, which is nothing but the standard deviation computed from the sample. We'll compute the standard deviation from the sample and then we will use it for our population mean testing process. So in both the cases, the null hypothesis is mu equal to mu naught, which means the average height of an Indian male is equal to 165 centimeters. Alternate is not equal to 165 centimeters. Depending on whether the population variance is known or not known, we'll use either the normal distribution or the t distribution. If we see in the second case, we are calling it based on the t distribution with n-1 degrees of freedom, whereas in the first case we are going ahead with a standard normal distribution with mean 0 and variance equal to 1. And if at all the sample size is much larger, probably greater than 30, 40, 50, if the sample size is much larger, and even though the population variance is not known and we have to go ahead with the sample, we all know that the t distribution converges to a large extent with the normal distribution, standard normal distribution. So that's where instead of using the t distribution, we can go ahead using the normal 0 1 kind standard normal distribution, especially if the variance of the population is not known but the sample size is very large. Now, how do I use these two kind of test statistics in our numericals? That's one thing I suggest, that we look at the two numericals here, and based on that, let's derive some of our conclusions. Look at the first numerical here. So, the average IQ, these many students we are considering as a part of our sample. So, N in this above, depending on whether the population variance is given or not given, I'll choose whether I need to go with the normal or the t distribution. Fair enough. So our sample size is 50. So the average is found to be 105 for the sample. For the sample, the average IQ was 105, which means our x bar is 105. Carry out a test to determine whether the average IQ is greater than 100. Greater than 100 is what I have to test. Alright. And it is given that it is normally distributed. So very important point needs to be there. If we see the question, we are talking about the population mean of normally distributed population itself. And it's also said that from the previous studies, the standard deviation is approximately 20, which means the population standard deviation is known. Now, so which means I will be using the first mechanism, wherein will be the test statistic which we will be using is the sample mean minus the hypothesized mean divided by sigma by root n. That will follow a standard normal distribution. Now let's try out that numerical. Right, let me take it up into a spreadsheet and then we'll try it. Alright, so how do I calculate that? What is the information that is available? The n, which is the sample size. Right, so probably let me call it as hypothesis testing for population mean, population variances known. So on these lines, the numerical which we are talking of, there is a sample size of 50. The population standard deviation sigma, the population standard deviation sigma is already known. The sigma is given to be 20. The sample mean x bar is given to be 105 and the hypothesized mean is given to be 100. So this is the data that is given in the numerical. Now we can always go with the test statistic. The test statistic in this case goes as x bar minus mu divided by sigma by root n. So what is our null hypothesis here?